Okay, so today is day one of our new unit. We're going to do equations of lines and planes in the next 2 units. So I'm here with my favorite class. So everybody say hi really loud. Hi. It's got to be louder than that. Hi. Perfect. Okay, so this is really awkward. It is. Like I won't make it up. Yes. So how do you feel about today?
Great. Great.
Good. Good. So next year's class will really enjoy this lesson, right? Okay. All right. So we're going to look at the stuff that we've already done, talking about lines and everything like that, but now we're going to find equations for the lines. So just like in grade 9 when we found information about the lines, things like lines and slopes and everything like that, we're now going to attach an equation to it, because if we know an equation of a line, then we can extend that information and go further. So the most important part of an equation of a line is something called the direction vector. So it's right here. The direction vector is a vector that describes essentially the slope of the line. Okay? Remember back in grade 9 we had something y equals mx plus b, and the two important things that we needed for lines were the m, the slope, and b, the y-intercept. When we're doing it in algebraic vectors, we still need those information, except we don't have to be as specific as the y-intercept, we just need a point, but we do need a direction vector, which is kind of like the slope. Because if the direction vector is described as something like this, that direction vector looks a little bit different than something like that. So, how's the direction vector found? Well, the direction vector represents that same vector that we've already found before. We just didn't call it a direction vector. So in this case, if I have the direction vector from A to B, then of course the vector is AB. And we know that we find AB by doing B minus A. In this case then, it's going to be 5 minus minus 2 and 4 minus minus 7. So 5 minus minus 2 is 7. 4 minus minus 7 is 11, and we get our direction vector is 7, 11. So we know that the direction vector 7, 11 is going to describe the vector that I'm given there, but so will any scalar multiple of it. Because remember, the slope is just describing how steep something is. Well, the direction vector is telling us the same sort of idea. And if you think back to grade 9, you might have done rise over run and got something like 4 over 2, right, as your slope. And you could leave it and write it as 4 over 2, or you could reduce that to 2 over 1, and that would still be the same slope, right? Or you could do a scalar multiple of that. You could multiply the top and the bottom by 5 and say 20 over 10. That still would all be the same slope, wouldn't it? Same idea for these vectors. So we have 7, 11 is a vector, but so is any scalar multiple. And I'm representing that scalar multiple with the k part. So I could multiply it by 2 or 6 or negative ones as well, right? Because since I'm describing a line, I could describe the line in the positive direction or the negative direction, doesn't matter. So they're all called direction vectors. It's parallel to L, and there are an infinite number of direction vectors for every vector, because you can just multiply it by any scalar multiple, not just 1, 2, 3, 4, but any decimals and any negative direction in any direction you want.